let us solve the next question where we have to determine the principal strain and the principal directions. We have determined the principal stresses and the principal directions. Now we will be determining for strain. So we know that strain tensor is given by epsilon, I'll just call it as ij in order to generalize it. So it is epsilon x gamma xy by 2 gamma xz by 2 gamma xy by 2 epsilon y gamma yz by 2 gamma xz by 2 gamma yz by 2 and then epsilon z. Alright, let us just fill in the respective values. It's 0.1, 0.15, minus 0.04, 0.15, minus 0.05, 0.05, minus 0.04, 0.05 and then 0.05. So first we have to find out the invariance of strain. How we had found out invariance of stress. Similarly, we are going to find out the invariance of strain tensor, that is J1, J2, J3. So J1 is epsilon x plus epsilon y plus epsilon z, that is 0.1 minus 0.05 plus 0.05, which results in 0.1. And J2 is epsilon x into epsilon y plus epsilon y into epsilon z plus epsilon z into epsilon x minus 1 by 4 times gamma square xy plus gamma square yz plus gamma square zx. Alright, so the values are 0.1 into minus 0.05 plus minus 0.05 into 0.05 plus 0.05 into 0.1 minus 1 by 4 times 0.3 square plus 0.1 square plus minus 0.04 whole square. This results in minus 0.0291. This is the value of J2. Now for J3. So J3 formula, how we are just calculated. First we are going to write down the formula that is going to be there for J3. Once we are going to find out all the invariants of stress, the next what we are going to do is find out the characteristic equation. So formula is epsilon x, epsilon y, epsilon z plus 1 by 4 times gamma xy, gamma yz, gamma zx minus epsilon x times gamma square yz minus epsilon y times gamma square zx minus epsilon z times gamma square xy. So this is the formula. Let us substitute the values into 0.05 plus 1 by 4 times 0.3 into 0.1 into minus 0.04 minus epsilon x is given by epsilon x is 0.1 into 0.1 whole square plus 0.05 into 0.08 whole square minus 0.05 into 0.3 whole square. So J3 reduces to minus 0.002145. Alright, so the cubic equation is epsilon cube minus 0.1 epsilon square minus 0.0291 epsilon plus 0.002145 is equal to 0. I have substituted it directly over here. Alright, so this is going to be the characteristic equation for strain. Well, if you want, I write the generalized form. It is epsilon cube minus j1 times epsilon square plus j2 times epsilon minus j3 is equal to 0. This is the generalized equation. Alright, So continuing further, we have this cos 3 theta is equal to 4 times cos cube theta minus 3 cos theta, or I can write cos cube theta minus 3 by 4 cos theta minus 1 by 4 cos 3 theta is equal to 0. We are going to compare this with respect to this. So that leads to epsilon is equal to r cos theta plus j1 by 3, or r cos theta plus 0.1 divided by 3, or I can write r cos theta plus 0.033. Substituting into this, it is r cos theta plus 0.033 whole cube minus 0.1 r cos theta plus 0.033 whole square minus 0.0291 r cos theta plus 0.033 plus 0.002145 equals 0. Now this, if we are going to solve it, finally it reduces to r cube cos cube theta minus 0.03251 r cos theta minus 0.00112 equals 0. Dividing this by r cube, so that we are going to use this standard equation. We are going to write it in terms of this. Hence it is going to be cos cube theta minus 0.03251 divided by r square cos theta, r square because we already have an r in the numerator, minus 0.00112 divided by r cube is equal to 0. So I write down the standard form again. So it is cos cube theta minus 3 by 4 times cos theta minus 1 by 4 times cos 3 theta is equal to 0. Or see here, cos cube theta minus cos theta. That means 0.03251 by r square is equal to 3 by 4. Then minus 1 by 4 cos 3 theta is equal to 0.00112 divided by r cube. So I can write it as 0.03251 by r square is equal to 3 by 4. Upon solving this, you will get r value as 0.2082. Then 0.00112 by r cube is equal to 1 by 4 cos 3 theta. If you solve this, you will get the value of, first you will get the value of 3 theta as 60 degree, or theta is equal to 60 degree divided by 3, that is 20 degree. So we have theta 1, theta 2, theta 3. So theta 1 is going to be, write it as, theta 1 is going to be 20 degree, and then theta 2 is theta 1 plus 80 degree. So that is 20 plus 80, it is going to be 100 degree. Now theta 3 is going to be theta 1 plus 120 degrees, that is going to be 20 plus 120, 140 degrees. Okay, I can write epsilon 1 as r1 cos theta 1 plus j1 divided by 3. After substituting, we will get epsilon 1 value as 0.228. Then epsilon 2 is r2 cos, no need to call it as r2, r remains the same, we will just call it as r1. So because r value is same, so r cos theta 2 plus j1 divided by 3. Substitute it, you will get the value as minus 0.0031. Epsilon 3 is r cos theta 3 plus j1 divided by 3, that is minus 0.126. So we have already done this in stress. Same thing we are going to do it in strain. So there is going to be no much difference. The values, everything with respect to the formulas, only sigma and epsilon are going to be interchanged. In the place of stress, we are just going to substitute strain. So definitely there is going to be no much difference. So whatever is the formulas that we have done in the previous class with respect to stress, same thing is applicable for strain, hence solving of it is going to be completely useful, and it is also going to be easy. This particular problem, it might look like it is lengthy, but if you understand the simple formulas and if you remember the invariance of stress that is present, then it is going to be simple for you to solve. So we have found only the principal stresses and then the principal stresses for now. Now we still need to continue in order to solve the principal directions. So solving for principal directions, we are going to be utilizing writing every single epsilon 1, epsilon 2, epsilon 3 as a matrix. First we need to write them down as a matrix, and then only we are going to solve them out. Alright, so next is to find principal directions. So this is principal strain. Alright, so for the first one, that is we are going to find the principal direction for epsilon 1. So whatever is the matrix that was written over here initially in the beginning, we are going to make use of this. We have found principal strain, now it is time for principal directions. So I am going to rewrite the matrix as 0.1 minus epsilon 1, 0.15 minus 0.04, 0.15. Only the principal diagonal elements will be changed. Alright, the rest are going to remain the same. So minus 0.04, 0.05, 0.05 minus epsilon 1. If you substitute your epsilon 1, that is 0.0228, then you will be left with minus 0.128, 0.15 minus 0.04, 0.15 minus 0.278, 0.05, then minus 0.04, 0.05 minus 0.178. Alright, let us take up A1, B1, C1. A1 is minus 0.278, 0.05, 0.05 minus 0.178. Okay, A1 is nothing but I will be eliminating this and I will be considering this particular set. So I am going to find a determinant of it. Okay, so determinant of this will be 0.046. Next, for A2, I will ignore this, I will consider this. Let us call it as B1. A1, then B1. So it's going to be minus, please don't forget the minus, 0.15 minus 0.04, 0.05 minus 0.178. Solve for it, you will get it as 0.0247. Then C1. For C1, it's going to be, excluding this, we will be considering these four values. If in the problem in the final exam, we're going to ask you to calculate principal stress and principal direction, or principal strain and principal direction, don't get scared with respect to the length of the problem. It will be asked for 20 marks completely. Okay, so and this value is minus 0.0036. Finally, take the square root and summation of all the squares. Okay, you will get 0.053. So direction cosines, that is the principal directions. L1 is A1 divided by under root of A1 square plus B1 square plus C1 square, that is 0.883. Then M1 is B1 divided by under root of A1 a1 square plus b1 square plus c1 square, that is 0.464. Then n1 is equal to c1 divided by under root of a1 square plus b1 square plus c1 square, that is minus 0.068. So we have found out for epsilon 1. Now for epsilon 2, similarly I'll just write down the values, kindly solve it. First I'll write the matrix. The matrix that is going to be 0.1031, 0.15 minus 0.04, 0.15 minus 0.0469, 0.05 minus 0.04, 0.05, 0.0531, and then the value of A2 is minus 0.00499, B2 is minus 0.0099, C2 is 0.00562, and under root of A2 square plus B2 square plus C2 square is going to be 0.0125. Then L2 is minus 0.399, M2 is minus 0.797, and then N2 is 0.45. Similarly, for epsilon 3, the matrix is going to be 0.226, 0.15 minus 0.04, then 0.15, 0.076, 0.05 minus 0.04, 0.05, 0.176. So even for epsilon 2, the principal diagonal elements have to be subtracted by the value of epsilon 2. For epsilon 3, principal diagonal elements have to be subtracted by epsilon 3. After that, you will be getting these matrices. Then the value of A3 is 0.0109, and then the value of B3 is minus 0.0284, value of C3 is 0.01054, value of under root A3 square plus B3 square plus C3 square is 0.0322. Then L3 is 0.338, M3 is minus 0.882, N3 is 0.327. If you solve for all these things, you will get your 20 marks. Alright, so this ends the problem.